All right. Let's have a look. You'll get a little bit of time to work. You guys are going to be, just kind of FYI, we're going to be taking this looks like our SBAC test is going to be starting on the 25th of April. So I want to make sure this is going to be a real push to get the last curriculum that we need done. I also want to build in some review. We're going to start, I might even do a couple just simple review questions today, just to kind of get you guys thinking along the lines of doing well on SBAC and SAT. So it's really killing two birds with one stone. So they're the same kinds of questions. And I know a lot of you are going to be taking SATs in May. I know they're coming up in May, and then you might be taking them, I think it's May. There might be 2 sessions in the spring, but you can do this another session again in the fall. And so I really want to get you thinking in terms of how to apply the stuff that we know in a smart way on standardized tests. Okay, but for today, the main topic for today, we want to talk about, well, I'm not going to give it away yet. You'll see. I'll let you know when we get to the main point. I'll let you know. But let's just take a concept like this. What if we have the volume of this brick? It's or a big lump of concrete. It's a rectangular prism, right? We know the volume is 1,200, and we know that the width is 12, and the length or the depth is 9, and the height is unknown. How could we find the height?
Isn't length times width times height the volume?
Okay, good. So one thing we could start with then, we could start with the idea that 12 times 9 times h equals 1,200, right?
So take 12 times h divided by 1,200 and you get the answer.
Okay, so 12, say it again.
12 times 7, or 9. I thought it was 7.
Okay.
And then divided by 1,200.
Okay, we could do that. Sure. So what is 12 times 9?
I don't know, I'm not going to.
108. Okay, so that's one way we could do this. You're right. We could say 108 h equals 1,200 and divide each by 108. That's fine. All right, so then we would just go divided by 108, divided by 108, and cancel those. And then we could just simplify that, right? Okay, what's another alternative way to maybe do this? And that's fine, that works. I mean, it's the same kind of thing, but instead of, is there a way, rather than multiplying the 12 and the 9 first, could we do something maybe to make this a little easier? Does one of these obviously divide into 1,200? Okay, 12 goes into 1,200 pretty easily, doesn't it, right? So we could divide each by 12, and those cancel, and this becomes, what is this equal to? So then we just get 9h equals 100, and that's a little bit easier for actually to deal with, isn't it? Right? You see the point? Either one's going to give us the same answer, but maybe this is a simpler thing to do. If we divide each side by 9, then h is 100 divided by 9. Now let's say we want to actually write this as a mixed number, which we don't normally, right? But let's just say we're going to go back to middle school here for a little bit, and we're going to write this as a mixed number. So h equals 100 over 9. How do I divide that out? Using long division. Oh, what goes where? Okay, I got 100 goes inside the, is that the dividend? Yeah, it must be the dividend. And I don't even remember. It goes inside the division bracket. It's got some fancy name, but I forget it. And then the 9 goes where? Out front. Okay, so the denominator goes out front, the numerator goes inside. Good. And then what?
9 goes into 10 one time. So
1 time.
9 times 1 is 9.
And then what?
Minus 9 is 1.
Okay, then we subtract. Good. And we get 1.
Then you drop the 0 down.
Drop the 0.
9 goes into 10 one time again.
Okay.
1 times 9 is 9.
Good. And then we subtract, and we get 1 left over. What's that?
11 and 1.
11 and 1/9. So that's the remainder, isn't it? That's what remains over the denominator, right? So we end up then with 11 and 1/9.
I have no idea how to do that.
Sure.
Long division.
In the 5th grade when we were learning that, I was in the low, like the medium group, and I got moved to the high, and they were past that.
Well, let's.
And we hadn't got there yet, and I never learned how to do it.
Okay, well let's you'll learn right now. But let's practice
Yeah,
one.
and I never learned how to do long division.
No, I have no idea what that even means.
Okay, so let's practice this then, because it's not a big deal. So when we're doing long division, we're going to take the number, the numerator, or the denominator that's outside, and we're going to ask, does it divide into that digit? No, it doesn't divide evenly into 1, so we scoot over. Does 3 divide evenly into 17?
Yeah.
It doesn't divide,
Fits in.
it fits into 17, doesn't it? How many times does 3 divide into
5 times.
5? Okay, so it divides in 5 times, then we're going to multiply 5 by 3 and get 15, and we'll subtract that to see what's left
From
over.
178.
No, just from 17.
17.
Just from 17. So 17 minus 15 is
2.
2. Okay? And then we'll drop the 8 down, and now we start over again. 3 divides into 28 how many times? Say it again.
9.
9, good. 9 times 3 is 27, and we'll subtract. And then we get 1 left over, and 3, of course, won't go into 1. That's our remainder, right? So the answer is,
59.
so in other words, 178 over 3 equals, oops, 59 and 1/3, which technically is 59 plus 1/3, right? But we write it as, using mixed numbers, we just write 59 and 1/3, right? Okay? So why do I bring this up? Okay, because the topic for today, think about the stuff we've done in the last couple of days. We've done a lot of stuff with polynomials, right? We learned how to, well, I guess, I mean, you guys already knew how to add and subtract them, and probably even knew how to multiply, but I just showed you some simpler techniques for being organized when you multiply them, right? But we don't know how to divide yet, right? And so we're going to practice dividing polynomials. And the process for dividing polynomials is long division. Same process we use for numbers. We're going to use, and don't, I know that it looks like this is going to be terrible. It's not. It's really not. You're just going to follow the same process you did before, and it works fine. So don't panic. Just watch closely, and then you'll get some practice on this stuff. I gave you an assignment with only 4 problems, because they take a little while to do. I mean, it's not like it's just super quick, right? So 4 is it. But I think if you do 4 of them, that's enough. You can always reload one and get extra practice if you want to. During the review for this section, I'll give you a couple more to do, you know. But, if you need more, finish the assignment. You realize if you want to get more practice, you can reload the assignment, and it'll only take your highest grade. So, like, if you reload the assignment up and you say, that one's, I can skip that one, just don't bother. I mean, just skip it and go to the next one, go to the next one. Get some additional practice that way. Your high grade on that assignment is already in the grade book. It's done. You can't hurt your score by reattempting a quiz, okay, or an assignment. Okay, so let's set this up then. So we said the numerator goes, or the denominator goes where? No, the denominator goes out front, doesn't it? If we look at that last example, the 3 goes out front, right? The numerator goes inside. And so then we've got x minus 1 out front, right? And the numerator goes inside, right? Okay, but think about the stuff we did the other day when we were multiplying polynomials and we had to keep track of like terms. Remember that we always had to hold a column for every power of x. Multiplication and division are the same way, right? They're similar, and so the same rule applies. We've got to hold a column for every power of x, even if we're missing a power of x up here, if we're missing a term. So what am I going to write in here? 3x cubed minus 8x squared. What comes next? Plus 11. Okay, but I'm missing the x term, aren't I? Right? You see that? There's no x term, so what must the coefficient of x be?
Just x.
If it doesn't show up, what must x be being multiplied by?
1.
No.
0?
0, yeah, right?
Oh, yeah.
There's a missing term there, so we need to add a 0x to hold that column, right? Because we need to preserve that column for that power of x. And then it skips on over to our constant, which is plus 11, okay? Now, what about the denominator? Do you have to hold all? You actually don't. You really don't. On the denominator, you'll see why. When you distribute through on the denominator, the product that you're going to write always is going to go underneath the original numerator, right? And so you don't, like if this were something like x squared minus 1, you really wouldn't have to write that as x squared plus 0x minus 1. You could still just write it as x squared minus 1. It'd be fine, okay? In fact, I wonder if we should just do that. Yeah, let's do that. I'm just going to make this x squared minus 1. Okay? So what do we do then? We're just going to ask the question, how many times does x squared minus 1 divide into 3x cubed? And really all we care about is just the x squared part. So we're going to ask, how many times does the leading term there divide into the leading term there? In other words, 3x cubed divided by x squared equals what?
3x.
3x, right?
Yeah.
Everybody see that? 3x is our answer, so that's what goes there.
Because when you divide, you subtract instead of adding.
Right. You subtract, when you divide like basis, you subtract the exponents, right? Okay, so 3x cubed divided by x squared is 3x. What do you suppose we do next? When I get a number up here, what did I do?
Sort of subtract.
Well, first I multiplied, right? And then I subtracted that product. Okay, so for long division involving polynomials, we'll do the same thing. We're just going to multiply 3x by whatever the polynomial is out front. 3x times x squared is what? That's 3x cubed, right? 3x times negative 1 is what? Negative 3x, right? So what column does that go in?
The 0.
Right there. Okay, so we get minus 3x. And then all we're going to do here is we're going to, I want you to do it this way too. It's really easy to lose track of what you're doing. We're going to subtract the whole thing in parentheses, okay? And then we'll just subtract vertically. We've got the like terms already lined up then. So 3x cubed minus 3x cubed cancels. That's why we picked 3x, right? Negative 8x squared minus 0 means what? Yeah, I'm just going to bring that down, aren't I? Negative 8x squared, right? 0 minus negative 3x is what? Positive 3x. And then I'll bring down the 11. And we'll start over. Okay? You see what I'm saying?
0
Okay.
minus 3x equals.
0 minus negative 3x.
Oh, okay.
Right? So you're always, remember, when you're subtracting here, you're always going to subtract out front whatever's inside, right? So it's 0 minus that, negative 3x. So it becomes a plus 3x. Okay? So then we start over. Okay, so then we say, okay, now how many times now does x squared divide into negative 8x squared? So negative 8x squared divided by x squared equals what? No. What happens to the x squared over x squared?
They cancel out.
They cancel. So what do I get?
Negative 8.
So that's my next term. And what do I do there then? Once I get a number up here, I multiply, yeah, right? So I'm going to distribute this over there. Negative 8 times x squared is negative 8x squared. Negative 8 times negative 1 is plus 8, so that goes there. And we're going to subtract the whole thing. So I put a negative out front and put it all in parentheses. Negative 8x squared minus negative 8x squared cancels, correct?
Yep.
Okay. 3x we bring down. 11 minus 8 is, and that's my remainder, isn't it? Because now x squared won't divide into x evenly. And so that ends up being my remainder. So what's the answer then?
3x plus 3.
So yeah, so this whole thing is equal to 3x minus 8, right?
Is it 3x squared? Or no, never mind. I thought that. Like,
No, I think it's just an
arrow.
arrow.
Yeah.
So 3x minus 8 plus my remainder
3x plus 3.
divided by what?
X squared.
Yeah. By, that's supposed to be squared, isn't it? Something like that. Divided by. There's my answer. Okay? Make sense? Sort of, let's do another one. Pull up another one. There we go. Yeah. I don't know. Could be. She's always got a blanket. She comes, yeah.
Corey.
Okay. Okay, so.
What did you say?
What about this one then? What's going to go where? Now, see if everybody can walk through this whole process here. So what goes inside, what goes outside?
The bottom one goes outside.
Bottom one goes outside. Okay, so we're going to have outside, we've got 4x cubed plus x squared plus 3x plus 5. Inside, what's the first term I'm going to write?
4x
4x to the fourth plus,
3x.
no,
0.
x cubed
Oh, that's what.
plus
0x.
0x.
plus 0. Okay, good.
Do we really have to write those?
Yeah, you do. You really have to. Inside the brackets, you got to have every column. We're starting at x to the fourth, so we know we're going to have 5 columns. X to the fourth, x cubed, x squared, x to the 1, and
Oh, because on the other side you've got those.
right. On the outside, if I were missing one like last time, I don't have to include extra columns out here because when I distribute, I'll just put the products in the right column inside, right? Okay, so let's start here then. We'll start yellow. So what are we trying to decide first? What's the first? How do I know what goes up here? Okay, ratio, right, we're dividing ratio of the leading terms, right? So we want to know how many times does 4x cubed divide into 4x to the fourth? Well, that's actually pretty easy, isn't it? 4x to the fourth over 4x cubed equals, what happens?
4x.
So what happens to the fours?
They
4
cancel
over
out.
4 reduces to 1. X to the fourth over x cubed is what?
X. So
X.
it's just x.
Yeah, it's just x. So the first term of our answer is just x. Okay? So then we'll distribute. Right?
Why do you have to distribute?
Because that's the long division process, right? Up here in our answers with numbers, when we got the 5, we multiplied the 5 by the 3. But this time, instead of just a 3 out there, we've got a polynomial. So we got, when we multiply by a polynomial, it means we distribute, right? Okay, so then, what's that going to give us? X times 4x cubed. What's that going to be, Cam? X times 4x cubed is what?
X times 4x cubed.
Mm-hmm.
4x cubed. Or, no, just add them, right?
Yeah, you add them, yeah. So So there's a 1 there, right? So what's my power going to be? 4. There you go. Good. Okay, x times x squared. Okay, so plus x cubed. X times 3x. X times 5. Okay, now what? We're going to subtract. So what do I need? Tell me exactly what I need to write here, Kenzie. What am I going to write? So I'm going to put
Around the yellow.
negative.
4x.
Okay, but then remember, I gotta do that, right? To remind myself that I'm always going to be subtracting each term. I'm not just subtracting the first ones, right? Subtracting every one of them. So 4x to the 4th minus 4x to the 4th cancels, right? That's good. We knew that one had to cancel. X cubed minus x cubed. Let me make this minus bigger. So x cubed minus x cubed cancels, right? That's good. What about this? 6x squared minus 3x squared is 0 minus 5x. Okay, you got it, right? So now, does 4x cubed divide into 3x squared?
No.
It doesn't, right? As soon as the power of x down here is smaller than the power of x up there, we're done, right? Can't go any further. And so that was pretty quick. That's our remainder, right? So then what's the answer going to be?
X plus 3x squared minus 5x.
Yeah, so this whole thing equals x plus, here's our remainder. Oops, wrong color. 3x squared minus 5x. Do I need to put the plus 0? No, not anymore, right? We're just writing the simplest form up there. Divided by this whole thing, whatever's on the denominator, right? Because that's what remains over the denominator. Okay? I get it, it's a process. I mean, it's a long process, and you have to be careful, but it's really not like it's anything tremendously difficult, right? You just got to really pay attention to detail, or you can make a mistake. Okay? You good? All right, so let's just take a second, and I'm going to, oops. Okay. What's 23rd? Okay, let's just look at just a couple of these. And I think you're going to see there's some pretty good ways to do this stuff. Now there is, I mean, we can do this the algebraic way, and that's fine. But there's some tricks I want to show you too. Like, what if we want to choose the expression that's equivalent? What would you do solving this problem on a standardized test? SATs, SBAC, what would you do on this? Because you can be, I mean, by learning how to be smart about testing, you can get a lot of free points on those tests. You get a multiple choice one like this, what could you do? I mean, so you could like multiply that out, couldn't you? Right? If we multiplied this one out, there's one strategy. So we could multiply out this stuff. So if I distribute, this is going to give me, well, this is one of our patterns, isn't it? Right? If I have a plus b times a minus b, what pattern is that? No.
Oh, that would work too.
No, but that's the pattern we just did yesterday. Right? That's the pattern, and you may not remember this. But isn't that just a squared minus b squared? Right? So that works out to be x squared minus 16. That's the right answer. What if you don't remember the pattern? Well, that's all right. If you don't remember the pattern, just distribute. Right? X times x is x squared. That's bad color.
And then 4 times negative 4 is negative 16.
Yeah. X times x is, but we have to do more than that, right? We have to distribute each of these. So x times x is x squared. X times negative 4 is negative 4x. 4 times x is plus 4x. And 4 times negative 4 is negative 16. Well, those terms cancel. And I get x squared minus 16. So that's right. Okay. Does that make sense? Okay. We could do the same thing down here. X minus 4 times x minus 4. We could either use our pattern, or we could just write them, distribute. I don't care. The pattern's quicker, but either way. And we get something different there. What does our pattern tell us for that one? If we have a minus b squared, what's that tell us? A minus b squared is a squared minus what? 2ab, good. So 2 times x times 4 is minus 8x plus 16. So that's not equal to that. Obviously, couldn't we cancel these two out? Those aren't the same. Equivalent means the same as, right? So those two aren't the same. Everybody agree? Okay. Let me show you a trick, though. Here's a great trick. Now, you don't have a calculator on this one, but you don't really need a calculator. Whenever you get something like this where you're trying to evaluate stuff or see if things are equivalent, all you got to do is just pick a random value of x and plug it into each of those and see which one gives you the same number that this one gives you, right? So for example, what if we picked x equals
12.
10? Or, we don't have to even pick a big one. What if x equals 8? Or let's even do 6. What if x equals 6?
So it doesn't matter what it is?
It doesn't really matter. If you pick a bad number, you might get multiple ones that work. Like, what if you picked a 0? Then that can screw things up. Then you pick a different one. So we just pick a random number. If I let x equal 6, then what does x squared minus 16 become? X squared minus 16 becomes 36 minus 16, which is 20. Okay, so that's the value of this expression when x equals 6. What if I put x equals 6 in here? I'm going to get 10 times 2 is 20. Check. Right, let's just make sure none of the other ones do. Well, this isn't going to work, is it? If I put 6 in there, I'm going to get 36 plus some big number, plus it's a lot bigger than 20, isn't it? Everybody agree? Just cross it out. What if I put 6 in here? I'm going to get 36 minus 48 plus 16. That's not going to be 20 either, right? Do you get it? What would that number be? We get
26 or 28 or something like that.
20, we get negative 28. So that one we can cancel. And then if I put 6 in here, 6 minus 4 is 2 squared is 4. So that's got to be the winner.
Soup.
See what I'm saying? Isn't that a great trick?
Yep.
Whenever you're trying to pick things that are equivalent or show, like say, write this in, which one of these is written in simplified form? Well, it's going to be, simplified form means the same thing but written more simply. Pick some random values for the variables and plug them in and see which one matches. The thing on the SBAC where you have an advantage is you can take as much time as you want. There's no limit. You could do this for 10 days if you wanted to. I don't suggest you do that, but there's no reason to ever go fast on the SBAC, because you can, literally, you can take as much time as you want on every question. You're not going to need to, but you can, right? Let's do maybe one more of these. Where is this? Did you really?
Yeah.
I thought you actually did flip it.
Not even close. It's gotta be less. It's gotta be like a quarter full.
So where?
Yeah, we gotta cap that. It's not.
Yeah, no, I can't do that.
Really? You can't just chug water. Another 2 rounds.
Wait, where? Right here.
Oh, here it is.
Little bit. That'll, that's pretty good.
No, you got ours.
Oh, okay. Yeah.
I think it's good.
Have a flip off. Let's go. Yeah.
We've never had a good year.
You have.
I understand that qualified that because it's not
Oh,
that's
that's
when we get
a
qualified,
tough.
it's not our fault.
You don't feel
Right.
You just do it all.
Pretty
Don't
good.
qualify.
Very much.
You know, it's not our fault either.
Yeah.
Oh my gosh. I know so bad. Remember freshman year we came up through that try right?
Start session.
You know, looking around.
Last year's doing, we tried to find it.
You guys
That was our lowest on the last day of school.
meeting?
Wait, any,
It was so funny. I think our lowest was like 62 graders.
Oh, and then we were
Yeah.
he got like
We were blowing
that
that
I've
right.
never had
Qualified at all.
oh, I guess.
trouble. Maybe I used to or something. It was like hitting them. So.
Oh, yeah.
That was so bad.
Yeah. They both, those two were so high.
Sorry it's taking so long.
We go watch games.
Oh, shoot, I know where it is.
Did you see?
There it is.
He looks back, keeps reading. Double.
That wasn't it?
Trent,
That was pretty close.
Hasn't been read.
let's not do the water bottle challenge.
That was quiet the whole time.
That's what I thought. Okay, how about this one?
Oh, I know this one. Yes on all 2 of them.
Okay, so determine whether each expression is equivalent to x cubed plus 27. Mark yes or no. So we haven't quite talked about this yet. This is coming up when we talk about factoring polynomials. But how could we check this one? This is easy. What do we do?
Plug a random number.
Plug in a random value for x. Yeah. So why not 6? Let's just pick 6, right? So if we let x equal 6, what are we going to get? So we want to know if it's equivalent to this one up here. So what's that going to give us? 6 cubed plus, maybe 6 is kind of a big one. Let's pick,
Can you just do like one?
say it again.
Can you do one?
Yeah, we could. We could do 1. Okay, let's try 1.
Maybe. Like 2.
Okay, let's do 1. And if we, here's the deal. If we end up picking an answer that gives us, anyway, that's probably, if we get 0 for an answer, we want to pick a different one. That's an easy way to think about it, okay? So let's pick one. Like if we picked 3 or -3, that may not have been a good one to pick because we would have gotten some zeros up here. We want to pick a number that's not going to make anything 0, okay? So what about 1? If we pick 1, we're going to get 1 cubed, which is 1 plus 27, 28, right? What's this give us? This one right here is going to give us 1 minus 3 is -2, right? Times 1 plus 3 is 4 plus 9 is 13. Is -2 times 13 28? No. So that one's no, right? How about this one? Pick one. This is going to give us 4 times 1 minus 3 plus 9. What's that? So 1 times 7. Or, no, 4 times 7. Is that 28? It is. This one's 28. Yes. What about this guy? If I pick 1, I'm going to get 1 plus 3 is 4 cubed. That's 64, right? 4 times 4 is 16 times 4. That's not it either, right? That's so simple, isn't it? A great trick. Okay, and we'll cover that stuff next week. But
Next week.
next week.
All right.
No, you know what? You guys have been working so hard. Take next week off. Take next week off.
I didn't plan on that.
Okay, what about this one? What do you think? Choose an equivalent expression. There's that word again. Equivalent expression, right? What can we do? I mean, the math way to do it would be just to multiply everything out, right? And that's fine. We could square this out, multiply those out, and collect like terms and do the same for each of these. That's fine, right? But what's a way that we could trick the question?
Plug a number in.
Plug a number in. How about 1? Actually, we don't want 1, do we?
2.
Because 1's going to make that 0. Okay? So we could pick like 2. 2 would work. Okay, so if we let x equal 2, what are we going to get for each of these? This one right here is going to give us 7 squared is what? So that's going to be 49. Good. Minus, put in 2 there, I'm going to get 7 times 1. So 49 minus, huh? I'm plugging in 2, right? So 49 minus 7 would be 42. Okay, no big deal. We got that. That's what we're trying to find one like. So how about this guy? We're going to get 2 is going to give us 7 minus 2 minus 1 is 1, right? Equals 6. Well, 6 is not the right answer. Cross it off. What about the next one? So that's going to give us 4 times 7 equals 28. 28 is also not 42. Cross it off, right? How about this one? This one's going to give us 7 times, what's inside here? 7 minus 1. So that's equal to 7 times 6, right? Right, Wyatt?
Yeah.
Got that? Which is 42. So that's the one. Right? That's the winner. Get it? Man, you get so much mileage out of that one. I tell you what. Seriously, I think that might be worth
47, 50 bucks.
150 points on an SAT test. I'm not kidding. I mean, it's that big a deal. It's really a quick one. And then we could probably just verify, just for our own benefit, this isn't going to work either. We're going to get 2 times 7 times 1 is 14, so that's no good, right? Amazing, huh? All right. Full of good tricks, you'll find. All right.